Hi everybody, this is section 4.5 for our Math 211 class, Geometry, and we are going to look at proofs using congruent triangles in this section. So in the last few sections, we have been proving triangles are congruent through either side, 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 angle, side, angle, angle, side, or angle, side, angle. Now what we're going to do is we're going to use congruent triangles to prove parts of a triangle congruent. So sometimes we can prove a triangle is congruent, but we can't, like before that, we can't prove two sides are congruent. We can only prove, other sides or angles are. So the way to prove the sides we don't have enough information for, is to first prove the triangles are congruent. And then your last step will be to use a step called, and I've always been taught it is CPCTC, which is right here. And it stands for corresponding parts of congruent triangles are congruent. In your textbook, you will see they actually use CPOCTAC. They use the of and the are. I don't use it. I'm always going to say CPCTC. And again, it stands for corresponding parts of congruent triangles are congruent. All right, so we are going to start and we are going to look at a proof. And this proof says that we are given ray AB, so this ray right here, bisects angle CAD, so this angle up here. And then we also know that ray BA, so going from here up, bisects angle CBD. And we want to prove that angles 1 and angles 2 are congruent. So let's start off, list our statements and our reasons. So we have statements, and then we have reasons. So I'm going to put it up here. And reasons. Okay, first one is our given. So we're going to say we know that ray AB bisects angle CAD. And I'm only going to put that one to start with because I do know that that particular ray AB, it bisects angles C or angle CAD. So that tells me if it bisects this angle, remember bisect cuts it into two equal parts. So I know that angle CAB is congruent, this angle is congruent to DAB, angle DAB, and that is your definition of an angle bisector. All right, then next, we're going to go to the other given. I now know that ray BA bisects angle CBD, and that is a given. So what we're going to say now is if I have an angle that bisects another angle, and again, we're looking now down here at this angle, I know those two angles are congruent, those two smaller angles. So I'm going to say angle CBA is congruent to angle DBA. And again, this is going to be definition of an angle bisector. Now, you're probably like, well, why did she split it up? It's the same thing. You're right, but I can get information from this one, specific information from this given, and I can also get specific information from that one. And so I wanted to split them up to show where the information is coming from. These two angles right here for number 2 being congruent come from step 1, and these two angles are coming from step 3. Now, ultimately, I have to prove that angles 1 and 2 are congruent. So what we're going to do here is we are going to first prove the two triangles are congruent, and then we can prove that the angles are congruent. So first we have to prove the triangles are congruent. So step 5, if I look and I want to figure out my two triangles, or this triangle right here and this one right here. So what I'm going to do is we are going to, we know this angle is congruent to that one, and then these two. But the two triangles, I know, and this is one, if you always see it, put it on there. AB is congruent to AB through our reflexive property. So here's AB right here. And that's our reflexive property of congruence. Once I have that property in there, I now know that I can prove the two triangles are congruent through angle, side, angle. So I'm going to say that triangle, I'm going to name it ACB. So I'm going to go ACB is congruent to, and then you have to keep the order the same. So I'm going to have to do ADB for the other one. So triangle ADB. And I said it earlier, it is angle, side, angle postulate. And now, once I do that, once I prove the two triangles are congruent, we know that through our definition of congruent triangles, or congruent parts of corresponding parts of congruent triangles are congruent, I know that angle 1 is congruent to angle 2, and that is going to be our, simply write CPC/TC. That's all you have to do. I call it a PT sandwich with C's for the bread, if that helps you remember how to put it in the order. Okay, here, this is kind of cool because we're looking at a real life instance when, we use triangles to help us in real life. And again, this is back in, ancient times, but we didn't have GPS or, things that we could, lasers to measure things. So we have, and I think it's Thales, I'm not sure, so I may be pronouncing it wrong. If you're Greek, let me know. And you may not know, but he is a Greek philosopher that is said to have developed a method to measure the distance to a ship at sea. He made a compass by nailing two sticks together, and standing at the top of a tower, he would hold one stick vertical, so straight up and down, and tilt the other one until he could see ship S along the line of the tilted stick. So here's the big tower. Here he is standing here. I have fabulous drawing skills. My daughter is so proud of me. And then here is his vertical stick. I think that's straight up and down. And then he tilts one until he can see the ship. Now there's our ship at sea. And then with this compass setting, so he would keep that compass setting and basically take this stick that he has there, this stick right here, flip it around until he could point it towards a landmark that he knew, so something like a tree on land, where he knew the distance. So if he knew the distance to this tree, or he could measure it from the base of the tower out, he could find how far out the ship was. And we're going to do a proof to prove what he did works. Okay, so here you have a much better drawing to look at. And we're going to solve this proof. So I'm going to use my statements. And my reasons. Okay, and the first one obviously is going to be our given. And I'm going to start with the first given, which is angle TRS and TRL are right angles. Okay. What did we say before? If we have a given that tells us we have right angles, what's the next step we automatically have to do? Hopefully, you said, oh, I know, we have to say that those are congruent through our definition of right angles. And that is just our definition of right angles. All right, now, really what we want to do to prove, because we are proving that this distance from here to here and this distance from here to here, make that black, it's a little easier to see, is the same. So we want to first prove the two triangles are congruent. And when I say those two triangles, we're going to look at, here's one triangle, and here's the other one that we're proving congruent. So what is another piece of information we can get? We've used our first given, so maybe now it would be good, let's put in our other given, angle RTS is congruent to angle RTL, and that is, again, our given. So I really can't get, other than that we know those angles are congruent, I don't have any other information from that. But if I look at the two triangles I'm proving congruent, what's one thing that sticks out to you that we've used in other proofs that's common when we're proving our triangles are congruent? Hopefully, you said, and you mentioned, we have TR. TR is congruent to TR, and that is our reflexive property. Of congruence. Okay. So now, number 5, I have enough information. I know that we have, I'm going to do a little erasing so we can see stuff here. All right, right now I know that I have right angles here. And I also know that RTS and RTL, so these angles are congruent because the measurement of the sticks, the angle never changed. And then I also know about TL. So how can I prove those two triangles are congruent? I can prove, and again, this is where you have to keep the order of the same letters, so it's TRS is congruent to triangle TRL. And that is going to be through angle, side, angle. And then once we know angle, side, angle, all we have to do is take that last step, the prove. We can prove. So now we know, because the triangles are congruent, that RS is congruent to RL. And that is going to be your CPC-TC. So it's not bad. The hardest part is proving the triangle is congruent. The last step is easy. All right, so here, so far, the triangles we've looked at have been adjacent to each other, but they really haven't been overlapping. But there are going to be times when you will have triangles that overlap. So here, they wanted to prove, like, let's say we were proving triangle ACB CD, so this one right here, was congruent to ECB, this triangle here. So notice they have an overlapping part. And that's important when you're doing your proof, because they may not have the reflexive property of a side, but maybe, like you can see down here, they have an angle in common. So here, if we were doing a proof, their common angle is C, so you could say angle C is congruent to angle C, and the reason would be the reflexive property. All right, we have one more proof to do for this section. It's the last thing we're going to do for this section. So I'm going to start off and put my statements and my reasons. Okay, so we will start off always with our given. And here, again, we know that angle ZXW is congruent to angle YWX. And then also, because there are two angles congruent, I'm going to put this one in here too. ZWX is congruent to angle YXW. Now, what we need to do here is really the best thing to do is we kind of need to separate these two triangles. We need to figure out what two triangles we are proving congruent. And so it looks like if we know ZXW is right here, and ZXW is here, YXW is right there, and then ZWX is this big angle, and YXW is right here, that I'm going to shade them two different colors. So this is the first triangle, and I'm going to call it triangle, let's see, ZWX. And then the other triangle is going to be right here. And of course, if I shade with my red, it's going to go over the blue. And that's going to be triangle, we're going to keep the same order. So it's going to be YXW. And I use the angle markings to help me. So how can I prove those two angles are congruent? And really, if we look at them, they do overlap. And I find that they both share this segment down here at the bottom. So I could say for step 2 that WX is congruent to WX, and that is our reflexive property of congruence. And then, because I have the two angles and the side, I can prove the two triangles. I can prove triangle ZWX is congruent to triangle YXW, and this is going to be through side, or not side angle side, but angle side angle postulate. And then once I do that, now I know that segment ZW is congruent to segment YX, and that's just going to be through CPCTC. They aren't too bad, and again, I know you're not perfect at proofs. I want you to practice them, try them, get used to them. It's really about explaining your work, and the more you know the properties and the more you study those, the better off you are at doing the proofs. It's really about knowing the properties, the theorems, and the postulates.